हेलो स्टूडेंट्स, आज हम डिस्कस करेंगे सेल्फ एनर्जी ऑफ ए चार्ज्ड कंडक्टिंग स्फीयर एंड दिस इज सेकंड मेथड. Let me tell you about first method. We used the trick of energy density of electric field that is given by 1 by 2 epsilon node into E square. Okay, if you want to find out the total energy of a charged conducting sphere, then what you will do? You will integrate the energy density function over the given volume and you will get the total energy. Okay, so this was our first method. Now we will discuss second method, and here we will make use of the energy which is given by amount of work done and which is equal to potential into the amount of charge which is brought at a point where potential is V. Okay, and finally we will integrate this relation to get the total energy, self energy of a conducting charged sphere. So here we take a conductor and this conductor is of radius r. Let the radius of conductor is capital R, and what you are doing, you are charging it. Suppose we accumulated total charge Q on this sphere, and let us talk about the intermediate state where we have given a charge Q to this conducting sphere. You all know that when we give charge to a conducting sphere, it resides on its outer surface. Okay, so if you give Q charge to this conducting sphere, it will accumulate uniformly on the surface of this conducting sphere. Okay, so now tell me, what will be the potential of this conducting sphere? This potential will be equal to the charge Q by 4 pi epsilon node into the radius r. Okay, so if you deposit more charge on this conducting sphere, then you have to work against the electric field of this charge already accumulated on this conducting sphere. So if we bring another dq amount of charge here, then you have to work against the electric field, and that work done can be calculated using formula potential of the sphere into the charge which you are bringing further on this sphere. Okay, so if you want to find out the amount of work done dW to bring a charge dq on this charged sphere, that is given by this relation. Okay, so making use of this relation, we will find out the dW, and dW is V into dq, and V of this charged conducting sphere is this one, so this will be Q by 4 pi epsilon node into R. Okay, and then you have dq, this is d into q. Okay, now when we started charging this conducting sphere, initially it was neutral, so initial charge was 0 and you are to accumulate a total charge of q. So our variable, that is the amount of charge, that vary from 0 to q. So if you want to find out the total amount of work done to accumulate a charge of q on this conducting sphere, you have to integrate it. Okay, and this total amount of work done is stored as self energy of charged conducting sphere, which is given by integration 0 to total amount of charge, that is capital Q 4 by 4 pi epsilon node into r into dq. So here you see 1 by 4 pi epsilon node r, this is a constant and you can take it out of integration. So here you will get 1 by 4 pi epsilon node into r, and you are to integrate q dq. Here you see the power of q is 1, so after integration you will get q square divided by 2, and the limits of integration are 0, 0 to capital Q. So if you substitute this value, then you will get the self energy of conducting sphere that will be equal to 1 by 2 times of q square by 4 pi epsilon node into r. Okay, so this is the end of topic.